Hey, my little studlets, I hope you're having a great day, and I'm here with Professor McStud, and we are going to be talking about factoring, just getting some more factoring under our belt. So let's look at this first example here. Notice that my a, or my term in front of my square term, is a 1, so I can factor this by finding factors of 18 that add to get me to 9. That would be 6 and 3. And then, and it get me to negative 9, so really negative 6 and negative 3. So that is my factors there. Moving on to the second one, we have a difference of squares. Remember, it has to be subtraction. This is a perfect square. This is a perfect square. We take the square root of the first and square root of the second. Square root of the first, square root of the second, plus, minus. There we go. All right, now then you'll notice here that I don't have a 1 in front of our first term, or a, so I'm going to do the box method. This is not something you have to do, but I certainly think it's easier. So I have 2k squared and negative 12, so I'm finding factors of negative 24. Remember, you multiply those two together, that give me to 5. Negative 5, so it's going to be negative 8 and positive 3. So negative 8k and 3k, finding greatest common factors from each column and each row. And so we end up with 2k plus 3 times k minus 4, finding those greatest common factors. So that's it. Just kind of a quick review. Now then, here's the new part here. We have factoring that can be solved geometric problems involving area and the dimensions of the figure. So remember, the area, we talk about the area of a rectangle or a square. Remember, that's length times width, or base times height, both of those meaning that. So we know that the area is 3x squared minus 7x minus 6. Find the length and the width of the rectangle. So just because I have an expression here doesn't change the process. So if I told you that the area of a rectangle were 36, what were the length and width? Those are lots of different possibilities. Now, because we do have an expression, there's going to be one possibility here. So what I want to do, so if I told you that the area of this was 36, you would start finding things that multiply to 36. Okay, this is just an example. So like maybe 12 times 3, or 18 times 2, 36 times 1, 6 times 6. All of those, 9 times 4, would give you 36. So same concept here. So I'm finding but these are factors of 36. So I need to find factors of 3x squared minus 7x minus 6. So I'm going to find the factor, so I have 3x squared and minus 6. So basically I'm just factoring again. So I'm finding factors of negative 18 that get me to negative 7. So I think that's going to be negative 9 times 2. That gets me to negative, so negative 9x and 2x. Remember, finding greatest common factors each column and each row. So we get x minus 3 times 3x plus 2. And so that would be the length and the width. So which one's the length, which one's the width? That's irrelevant. So that's what you want to know. The area of a square this time is 4x squared plus 12x plus 9 was the length of each side of the square. Now, you know that this is, going to be multiplied by itself. That's the area of a square. So, but we still factor it the same way. You're not going to factor it any differently. So I have 4x squared and 9. So I'm finding factors of 36. That's going to get me to 12. That's going to be 6 and 6. So 6x and 6x. All of that being positive. Finding greatest common factors each column and each row. So you can see here that I have the same on each side. So essentially that's going to be 2x plus 3 times 2x plus 3. But it asks for what is the length of each side. So really just one of those would suffice for answering this question. Technically factoring, it is 2x plus 3 times 2x plus 3, but that's implied knowing that the area is a square, so it's going to be times itself. All right, and then we have example 6 here. We have the area of a rectangular lot is represented by 4x squared minus 19x minus 40. If the width is 7x plus 8, what is the length? So this one actually makes it a little bit easier. So I have 14x squared minus 19x minus 40. When I go to factor it, I know that one of them is 7x plus 8. So what I need to do is I need to look at the first term and the last term and really make sure that they multiply out to be together, and then it should all multiply together. So I really need this to be 14x. I have a 7x. To get to 14x, I need a 2x. And I have a minus 40 here. So to get from 8 to get to negative 40, I'm going to be minus 5. So you can do the inside and outside. So we have negative 35 plus 16. That does get you to negative 19. So what is the other length of the side? It's going to be this factor here. So 2x minus 5. Answering exactly what they wanted in the length. Or in the length. It's given the width. Again, those two are interchangeable. It could be the length or the width. Those two don't matter. Remember that the rectangle, so here we have a rectangle that has a length of 4x plus 3 and a width. How can you express the area? So now we're going back and we're trying to, and we're going back and basically multiplying. So we know that we have a rectangle here, and this is 4x plus 3, and this is 5x minus 2. What is the inside now? What is this area here? So now I'm going to multiply those two together. So 4x plus 3 times 5x minus 2. First outside, inside last. We have 20x squared minus 8x plus 15x minus 6. These two get together, so we have 20x squared plus 7x minus 6. So that's kind of reverting back to what you did learn before, and so now we know is this 20x squared plus 7x minus 6 would be the area of all of that. All right, so that's what I have for you. So kind of throwing in some geometry here with the area stuff, finding lengths of sides and whatnot. So that's it.